this quick video, I'm going to be showing you how you can fill out your 1.7 study guide for geometry for your Apex geometry course. So the first thing that we want to do is just kind of activate some prior knowledge. So these terms like linear pair and vertical angles, they might actually be familiar to you from your 8th grade math course when you probably first covered this. But just to recap, a linear pair, we can define this as two adjacent angles whose measures add up to 180 degrees. Okay, so that's how I can define it in less than 10 words. And then vertical angles, they're going to be a pair of opposite angles formed by intersecting lines. So we need intersecting lines in order to have vertical angles, and then for linear pairs, they just need to be right next to each other, almost like glued next to each other, where they share a common vertex and they also share a common ray. And they're going to line up together to form a straight line. So let's actually practice naming some linear pairs and vertical angles. So I just want to look at a straight line. So I'm going to look at like something like C and D, right? So CD is a straight line, and then I want to look at the two angles that form it, and then that's going to be my linear pair, right? So I have CVA, right? So I have angle CVA, and then so I have angle CVA, and then the other angle that makes up this straight line CD is AVD. So I have angle AVD. And then I see another, I want to look on the opposite end of my straight line. So if I was originally looking above my straight line CD, I'm going to now look below my straight line CD. And I'm going to look at the two angles that form CD from below. So I'm going to look at CVB. And then I'm also going to look at angle BVD. Okay. Now I see my other straight line that's being formed is line AB. So I'm actually going to focus on that. I'm going to look at the left of AB, and I see that these two angles that are forming this line AB from the left-hand side are CVA and CVB. So I have angle CVA and angle CVB. And then finally, on the right hand side of my line AB, these two angles that are being formed are AVD and BVD. So I have angle AVD and angle BVD. Okay. Now when I'm trying to identify my vertical angle pairs, I want to look at my intersecting lines. So my intersecting lines are CD and AB. And then I want to choose just one angle. So let's say that I'm going to choose angle CVB. So let me say I'm choosing angle CVB. My vertical angle is going to be whatever angle is opposite to angle CVB. So when I look at these two intersecting lines, the angle opposite to angle CVB is going to be angle AVD. So this is angle AVD. Right? Now, I already handled angle CVB and angle AVD, so I just want to look at whatever angles I didn't name so far. So one of them could be CVA, so I could have angle CVA. And the angle opposite to it is going to be angle BVD because it's directly across. Right. And I know that these are vertical angles because they're actually being formed by the same intersecting lines. That's really important in order to determine what your vertical angles look like. So whenever we have two lines intersect, they form four pairs of linear pairs. So they form four linear pairs and two pairs of vertical angles. And then all the linear pairs and vertical angles share the same vertex. So they all have a common vertex V. The only difference is that for linear pairs, they also share a common ray. And then for vertical angles, they do not share a common ray. So let's talk about the vertical angles theorem. So whenever we have vertical angles, something that we know about them is that vertical angles are congruent. So we know that they're congruent, right? And when I say that they're congruent, that means that they're going to be the same exact angle measure. So if one part of your vertical angle pair is 60 degrees, then the vertical angle to it will also be 60 degrees. So let's work through some examples, right? So let's say that I have angle AVC and angle BVD are vertical angles. So if angle AVC is 60 degrees, what is angle BVD? So I don't actually have to create a diagram in order to answer this problem, right? Because I already am given some critical information. I'm given that these two angles are vertical angles, and using my vertical angles theorem, I know that they're going to be congruent. So whatever angle AVC is going to be, angle BVD is going to be the same measure. So if angle AVC is 60 degrees, then angle BVD will also be 60 degrees. Let me just make it a little bit wider. There we go. And then for number 2, I have angle AVC and angle BVD are vertical angles. Angle CVB and angle BVD are linear pairs, so they add up to 180 degrees. So if angle AVC equals 75 degrees, what is the measure of angle CVB? Okay, so I know that angle AVC is 75 degrees, so I know that angle BVD must also be 75 degrees using my vertical angles are congruent theorem. And I know that BVD, which is 75 degrees, and CVB are going to be a linear pair. So I know that they add up to 180. So in order to find out what angle CVB equals, all I have to do is subtract 180 and 75. So 180 minus 75, right? I'm going to take the whole measure of the linear pair, which is 180 degrees, and I'm going to subtract it from the angle measure that I know, which is angle BVD, which is 75 degrees. So when I do that, I end up getting 105 degrees. And so that's going to be the measure of angle CVB. So let's talk about some intersecting lines, right? So whenever I'm talking about intersecting lines, I'm just talking about two lines that cross. Right? It could be more than two lines as well, but generally we're just talking about two lines that cross. Then perpendicular lines are two lines that intersect at right angles. So they form right angles. So two lines that intersect wider at right angles. There we go, less than 10 words. Okay, so let's actually draw an example of each pair of lines. So on your study guide, you actually have these lines already drawn for you, but then you just have to kind of manipulate them. So I'm going to draw intersecting lines that are not perpendicular. So I have one line here, and then I'm going to turn it around, and there we go. These two lines are intersecting, right? And they're not perpendicular because I did not make it so that, what's it called? Their intersection angles form right angles, right? These are kind of skewed angles. This looks like an acute angle, this looks like an obtuse angle. So these are intersecting lines that are not perpendicular. Now I'm talking about perpendicular lines, and I think that you can do this on Google Slides, right? It can actually, you can actually kind of snap it to be a 180 degree angle. So this is 180 degrees, right? And then you can snap this to be 180 degrees, but going vertically. So I'm going to align it to that side of the rectangle that shows up. And then when I just move it, right, I end up getting a perpendicular pair of lines, right? I know that this is perpendicular because it's forming that right angle, and I use that using kind of like that rectangle that showed up as a snap guide. So that's an example, right? So let's actually use notation to summarize the line relationship. So whenever we're talking about perpendicular lines, so it's saying line AB is perpendicular to line CD, I want to use a really special symbol. So let me see if I can access it. So I have that line AB, I would have ideally that double-sided line, that double arrow line over AB. But I'm going to insert a special character and see if they have the perpendicular symbol. So let me see, perpendicular, yep, they do. So this symbol right over here, it looks like an upside down T, means perpendicular. And I'm going to say that it's perpendicular to line CD. Okay. And then I want to complete the diagram to show the rule. So given any line AB and any point P, there's exactly one point that is both perpendicular to AB and passes through P. So what I'm going to use is actually, I'm going to draw a line, so I'm going to select an arrow, right? And I'm going to make sure that it's going 180 degrees up and down, and then I'm going to make sure that I have arrows on both ends. I'm going to make that a little bit thicker, okay? And then I want this line to go through P and also be perpendicular to AB. Okay, so just drew that. Let me just make sure that this is straight. There we go. Okay, so this is not only going through point P, but it's also perpendicular to line AB. Okay, our first question asks us how many lines are perpendicular to a given line through a given point, and based on the perpendicular rule, only one. Only one, right? And this is based on that perpendicular rule that we talked about. Let me try to put this up. Okay. There we go. And then what is the shortest path between a line and a point that is not on the line? And it's going to be a segment starting at the point and ending at the line that's perpendicular to the line. So a segment where we start at the point that's not on the line and ending at the line that is perpendicular to the line that you just drew. And then let me make sure that I'm spelling correctly. I'm going to make this wider just to help with the formatting. Okay. And let me just change the formatting slightly for this. Okay. There we go. So, right, we know that whenever we have, whenever we draw a line segment from this point and then we just drop it down in a perpendicular way to the line that we have, then that's going to be the shortest path that we can draw between the point, between a line and a point not on that line. So now that we know how to draw perpendicular bisectors, or actually perpendicular lines, what we can actually do is draw something called a perpendicular bisector. And the difference between a perpendicular line and a perpendicular bisector is a perpendicular bisector is specifically going through a segment, first of all. And it's also not only acting as a bisector in terms of the fact that it's cutting that segment into two congruent parts or in half, but it's also intersecting the segment at right angles. So it is a line, ray, or segment that goes through the segment's midpoint. That's how it cuts it through in half. And let me just make that a little bit smaller. There we go. And it intersects at right angles to the given line, to the given segment, right? So let's actually practice diagramming this, right? So the first thing that we want to do is, given this, right, we want to label the endpoints of our segment AB, and that's going to be what's cut in half by this perpendicular bisector. And then I have a midpoint M right over here. That's right in the middle. Okay, so I know that AM and MB are going to be two congruent parts. So I'm going to label AM as 5 centimeters. So this is 5 centimeters. Okay, and then BM is 5 centimeters. So let me label that as 5 centimeters. So I'm going to change this to 5 centimeters. Okay, and let me just put that right over there, and this is also 5 centimeters. So the whole thing is going to be 10 centimeters. Okay, and let me just move that. I want to draw a perpendicular bisector, right? So I'm going to draw this as, let's draw it as a line. Okay, so I'm going to draw a line. Go like 3 times, and then I'm gonna have it just go straight through that midpoint M. Okay, so to the back. Okay. And then let's just bring everything else to the front. Okay. So I have that my perpendicular bisector, this line right over here, is going through this point P, and is going through the midpoint of this line segment over here. So now I just want to kind of draw a conclusion. So I want to think about, why can't a line or ray have a perpendicular bisector, right? Why do perpendicular bisectors only go through segments, right? And the reason for that is because lines and rays, they go on forever and ever and ever. That's what that arrow at the end of that line represents, right? So if something goes on forever and ever and ever, you don't really have a midpoint, right? You don't really have like a halfway point that you can draw a line through, right? So the reason why lines or rays can't have perpendicular bisectors is because lines and rays don't have midpoints because they have infinite length, right? That's what that arrow at the end represents. So in order to find the middle of something, you have to be able to measure it. And you can't measure the length of a line or ray because it goes on forever and ever and ever to infinity. Okay, so that was lesson 1.7, right? That was the entire study guide. So once you finish this, you should be able to work on your quiz. If you have any questions, remember to just reach out. You can also ask them during class time, but good luck.